day. Welcome to the Indian Grain Storage Hub concept. This is a detailed report prepared by Pulse Australia for the Department of Agricultural, Fisheries, Forestries, and provides a number of practical initiatives for the Indian grain storage market to modernise. Part of this process, we're preparing a series of technical webinars, and these are developed to provide educational material across storage and handling, standards and marketing, blockchain, and practical on-the-ground investment initiatives. I'm Chris Orcutt. I'm the Director of Ag Perspectives, and I've been the lead consultant on this project. Today's webinar is entitled Grain Storage the Australian Way. Our subject matter expert is Chris Warwick, Director of Primary Business. A bit more about Chris. Chris grew up on a family farm near Horsham and has pursued a career in agriculture, focusing on helping farmers make more informed decisions. Chris operates an independent consulting business, Primary Business. Chris manages the GRDC-funded National Grain Storage Extension Project with a team of specialists operating across Australia. He's well informed and an expert in on-farm grain storage and storage systems in Australia. Welcome, Chris, and I'll hand over to you.
Thank you very much for the introduction. Great to be here today and to be able to share a bit about what we've learned in grain storage systems here in Australia, and hopefully they can translate or transfer across to other areas that might be looking to get into storage, so that people can be aware of what to consider, what to plan for, and what to expect when storing grain. So I'll go through different types of grain storage facilities, pros and cons of each type and where they might fit, and as I said, the considerations for setting up a storage facility and how you can set it up to make it easy to manage and successfully get grain out the other end at the same or better quality than what it went in.
Excellent. Thanks, Chris.
I'll share my screen. Okay, my contact details are on screen there. If people do have questions after this webinar, welcome to getting in contact with me via phone or email there. I'm happy to take questions. The common types of storage we have here in Australia, I'm just going to grab a pointer so you can see where can you see that, Dot? Yep, great. So the typical types of storage here in Australia I've got on screen. So cone bottom silos on the top left there, typically smaller size, 10 to 120 tonne, that can be transported straight from the factory on a truck, or they can be built much larger as a build on site type of storage. Then flat bottom silos are typically larger, 800 tonne up to I think 17,000 tonne. Typical sizes that tend to be economic are sort of in the 1 to 3,000 tonne range for larger flat bottom storage. And you can see this particular one has a filling conveyor across the top.
Yep. Top
middle there, we've got shed storage, typically 3,000 tonne and upwards. They become economical. They're another multi-purpose option, I guess you'd say. You can store machinery or hay on there, or grain in the years that you need to. In the top right, we've got bag storage. In that example, one bag in the corner of a paddock, but these can be set up at a centralised site, so they can be a central storage site, and really dependent on how well they're set up and what grain goes into them as to the length of time you can store grain in bags for. But typically here in Australia, a shorter term storage option. And then an option used predominantly by the bulk handlers here in Australia, but sometimes on farms as well, is the bunker storage. So a pad on the ground. This is a particularly well done one with concrete sides and even aeration cooling through that bunker. So they're the most common sort of storages we see here in Australia.
So which do you think I mean, what is the most, if you're looking at an on-farm kind of system, a smaller system, what would be the most common setup? The cone bottom kind of shed system, is that probably what most farmers would use?
The data shows us here in Australia about 80% of grain storage on farm is in silos, whether that be cone bottom or flat bottom.
Okay.
So vast majority is in silos, and then in the high yielding years, the big years, they overflow to sheds, bags, bunkers.
Yep.
So the considerations for anyone looking to invest in storage, the considerations I would encourage people to look at is, what's the purpose and function of the storage? What are we trying to do with it? And so then we can design it around that. Too often I hear of people go straight to price and look for the cheapest form of storage first. If the storage doesn't meet its purpose, it's not going to work out very cheap. It's going to work out pretty painful to manage. So looking at inloading and outloading logistics, how quickly do you want to take grain in, segregation, how long do you want to store grain for, and what other ways can we add value to the storage by either blending it, cleaning it, processing it in some way. If we're taking on the grain and putting it into storage, we might as well make the most amount of money out of it as we can. When we get down to the operating side of the storage, having a think about the availability of equipment or labour is one or both of those a limiting factor for our site, and that might be the availability of labour full stop, or the availability of skilled labour that we might need to account for. Workplace health and safety, always a big one that we need to consider. Pest management, prevention and treatment. So we need to assume we will have grain storage insects at some point. How are we going to manage for those? And how are we going to prevent to try and reduce the number of times that we have issues with pests? And then, of course, managing grain quality, which is really about managing moisture and temperature.
Yeah. And I imagine, as you say, that the initial design, you've got to allow in that design, if you do want to grow it and expand, how are you going to manage that in the longer term? So, it's about, I suppose, where you want to locate it, access to services, no doubt, all weather access, all of those kind of things are a big driver, because, these especially a silo investment is a long-term investment, isn't it?
Absolutely. We're looking at sort of 30 plus years, hopefully, that storage facility should last. So being able to expand to that and add new technology to it, to be able to keep up with the developments of transport. When transport becomes faster or larger scale, we need to be able to keep up with that. And then, as you say, geographically close to where we want to receive grain, or on the way to where we want to deliver grain to. So
Yeah.
no point taking delivery of grain in one direction and have to then reload it and turn it around to take it to market. So logistically, all weather access, and of course proximity to neighbours and other people that may be affected by dust or noise as well is, of course, consideration from a local planning perspective.
Yep.
So let's go through those considerations one at a time to explain a little bit more, without going into too much detail, what I'm talking about. So inload and outload logistics, is grain coming in small transports, in smaller trucks or even smaller loads? Is it multi-trailer trucks? Do we plan to use an auger or a conveyor system like this that's movable to each storage type? Or are we looking at having really quick turnarounds and having a system where you have a drive-over hopper, you tip the grain into that hopper, and then you select which silo it goes into through a centralised system? This centralised system in the photo on the top right has the ability to outload through that same system. So they would outload a batch of grain into what we call a garner bin, and then a truck simply pulls under and takes delivery of the grain out of that garner bin. So a lot less manual labour, the ability to segregate every load individually, whereas those simpler, cheaper systems, you would need to shift the auger every time a load come in if you wanted to segregate that grain. So pros and cons of each, but something worth thinking about And as you said, Chris, you might start with the system with an individual auger or conveyor, but develop that site so that you could put a belt underneath or a conveyor across the top of the
Yeah,
silos to enable segregation in the future expansion. So just thinking ahead to those possibilities.
absolutely. So you can move from, yeah, as you say, from an auger to a, kind of a fixed conveyor system. Yeah, so you got to allow in your plans, allow for that modernization, I suppose, of your
Yeah,
systems.
yeah,
Yeah,
absolutely. And it seems a really obvious point. When you look at it retrospectively, but a lot of people that I help through this process feel I don't need that much segregation, and then they get into testing the quality of grain coming in, and there'll be a load off spec or a load that hasn't met protein, or it's been frosted, or it's discoloured, and they want to segregate. That's the point of having segregations in their storage. But the hassle to shift the auger to a new silo just to segregate one load,
yes.
shifting the auger can take as long as it does to unload the truckload. So it
And
becomes
what
inefficient.
about weigh bridges as well, Chris? What are you seeing there? Probably 10 or 15 years ago in Australia, not many farms would have had them. But is that kind of an increasing, addition to kind of the on-farm storage systems?
It sure is, yeah. Weigh bridges, to know what's coming into your storage, but to also know what's going out, particularly for people using contract carters, selling off farm straight to port or to end user. To be able to weigh the grain before it leaves the farm is a lot safer than, of course, relying on the truck driver to go to the nearest weigh bridge or to weigh it when they arrive, and you're relying on someone else's bridge and that there's nothing lost along the way. So weigh bridges are absolutely becoming more popular. So too is airbags on trucks. So people are getting a rough gauge on their weight through the airbag on the truck is another way that people do it without having a weigh bridge.
Yep. Okay.
Some other, so that's more for silos we spoke about, inload, outload. If we're looking at sheds, there's a number of ways you can load a shed from the basic back the truck up and tip it in, and then push it up with a front end loader. You can unload into an auger and then drop it through the lid of a shed through a hole in the top. And then when it comes to outloading sheds, you can do it with a loader into a hopper like this and straight into the truck. There is machines purpose built for unloading sheds, and bunkers typically unloaded with a loader, as you can see in this photo. And grain bags that I mentioned have a specialised unloading machine there. So several ways you can do sheds, but all fairly practical, a little bit more labour intensive than silos. I mentioned segregation. Here's some examples of ways you can do segregation really efficiently and I think quite cleverly. So if you're going to go to the effort to test every load on the way in, why not segregate it as we're doing that testing? Otherwise, you could argue, what's the point of taking the test? You might as well just take a running sample and test it at the end. So here's one particularly neat system I have seen. So the truck comes to a drive-over hopper, into a small conveyor there, and then into a ring of silos, a circular ring. Here's the ring of silos. Here's the hopper that the truck is parked on. And so if you want to put the grain into any silo, this auger swings around the circle and can load any one of those silos quite quickly, shift between one silo and another. So a really efficient way to segregate. And it's also not too bad for grain storage hygiene. So some of those bigger central systems actually catch a little bit of grain and they're hard to really
Yeah.
clean out from a hygiene perspective. A system like this really clean
So
and efficient.
so that's a manual kind of move on the auger. You just kind of move it around, or
It
yeah.
could be manual, it could be set up to move on its own.
Okay. So it's kind of a hybrid system, the circular one, isn't it? Really,
It
kind of
is.
allows you
Yep.
the flexibility of the above kind of silo conveyors without the cost, I suppose.
That's right. Yes. Yeah. I quite like the system. And you can see this one, they've even fitted two rings of silos in, a
Yeah.
smaller ring and a larger ring. And so that of course, these ring of silos, they can swing both of these augers around and then outload straight into their processing shed.
Yeah.
which is mounted beside. The downside, if you like, of this system, and one of the few downsides I see, is that once it's built, that's the limit of how many storage cells you can fit in that system. But what people tend to do is have a guess at how much storage they want that level of segregation for. Once they grow beyond that, their separate stores are a larger size. They segregate at a larger scale than once they've outgrown this ring.
Yep. No, it's a good concept.
I have seen some here as well that start with a half ring to allow room for expansion. They don't fill the rings straight away. They start with a half ring. That works quite well as well. So you don't have to fill the whole ring at once. In fact, it'd be a good idea to allow room for expansion, even if you don't think you need it. Sheds really come down to how long grain's going to be stored for. If we intend to store grain for more than a few months, I'd expect we'll want to be able to fumigate. In a shed, that's really difficult because we can't hold the gas in there at a high enough concentration for a long enough period of time to kill the insects at all their life stages. So for people that go down the road of a shed, I always suggest have some gas-tight sealable storage available to fumigate when you need to. It would be naive to think you will never have to fumigate or deal with insects. So having an option when you need it. The other photo I've thrown in here is pit storage underground. So here in Australia, used predominantly for drought reserves. So people will, in good years, dig a hole, line it with plastic and put grain underground and then bury it, put it away for a drought year. I mentioned value adding. As I said, if we're going to the trouble of inloading grain and storing it and managing it, why not extract the maximum value out of that grain that we can? So whether that be packing it into 20 kilo bags or processing into a food product, or even drying it for customers with a batch dryer or a continuous flow dryer, so that people can do harvest when it suits them, when they need to, and deliver it to the central storage, and then the central storage can deal with that high moisture grain. All ways that we can value add to the grain that we're handling. I mentioned equipment and labour. So have we got labour that's skilled to be able to manage the storage, and then also skilled to be able to operate machinery and have the common sense to do it safely and practically, so we don't have grain mixed up or grain piles on the ground, equipment broken, and worse, people hurt or injured. So having skilled labour is really important.
Yep.
Access to electricity and reliability of that electricity. Generators are quite a popular choice to take that risk of unreliable electricity out, particularly when you look at aeration cooling and electric powered conveyors and systems like that. Typically draw more than the local grid can handle, so an on-site generator is very common.
So yeah, I was just about that. So they are very common, are they? Yeah. And I suppose in Australia, the cost of connecting to the mains electricity is quite onerous a lot of the time, isn't it? So
sure is,
yeah.
particularly when you go to three-phase for the bigger fans on aeration cooling for flat bottom silos, and outloaders are often three-phase power.
Yep.
So even a case I've seen, the power line went right past the site, and it was still cheaper to buy a generator and run that than to get the power connected to the grid, even though it was right there. So people do get the ability to that they control their own power. So if there's a power outage in the middle of harvest, they're not stuck, unable to unload. If bunkers are a choice, moving tarps over bunkers can be a potentially hazardous operation. So having equipment to do that safely, or enough people to do that safely, is really important. And of course, if you're going into bags, here's an example of a lot of bags at one central site. And they have cone bottom silos as well, the combination, quite a good mix. That will obviously require a lot more labour to manage those bags, not just at inload and outload, but maintaining them, patching holes, baiting for vermin, and keeping those bags in good quality.
Yep.
Workplace health and safety, of course, is paramount. Some people take a shortcut and say, well, the safest thing is not to climb a silo, so we won't put a ladder on it. And then a few years later, find they need to do some maintenance at the lid, or they want to check the quality of grain that's in the storage and have no way to access it safely. So I encourage people to go to the effort to build a safe walkway. Expect that we will need to access the top of a silo, so make a way to do it safely. Whether that's a handrail and a ladder on each silo, or as the picture shows here, one ladder and a centralised platform to walk across the top of the silos, but make it safe to do it. And of course, if we're handling fumigants or chemicals, we need the appropriate personal protective equipment designed for that particular product. So for
Yep.
phosphine, we need a mask that will take phosphine out. Pest management, really quickly, I won't go into the detail of it, but to understand there are two components of pest management. There's prevention. What can we do to stop insects and deter them from causing us a problem? And then if we do get them, when we get them, how do we control them? What's our measures to be able to control them? So there's structural treatments, there's aeration, cooling, monitoring. There are spray-on products to prevent against insects. The control options these days are all fumigants or controlled atmospheres. So, in able to control insects in grain storage, we need gas-tight sealable storage to hold that gas, that fumigant, for the required length of time.
So just going back to the prevention, sorry, Chris, if we just,
Sure.
I assume building new, a lot of, you can design the systems to allow, especially the temperature monitoring, I gather, which has a big impact on, I suppose, the development of insects. That's a pretty important piece of building the new storage system.
Absolutely. Monitoring is a good one in that can be retrofitted, can be added. Thankfully, because technology is advancing quite rapidly in that space at the moment. So we can upgrade technology in monitoring as it advances. Things like aeration, cooling are much more efficiently done at the time of build.
Yep.
But they also can be added. I don't know why you'd get a storage without aeration cooling. It just gives you so many benefits to cool the grain down, prevent mold, prevent insects, enables you to hold some grain that may be slightly off spec, slightly over moisture, might have some green grains in it, some pods, and so you can hold that safely until you've got time to blend it or dry it down or deal with it.
And like India, probably, more humid environments, having that ability to be able to aerate and
Yeah,
dry grain, it would be very important, no doubt.
hugely important. Now, we've done some work up in the far north of Australia with aeration cooling in the tropics. So they've got really challenging conditions up there, and they're finding aeration cooling to be the difference between able to store and not able to store.
Yeah.
So huge benefits in
Yep.
aeration cool. And people sometimes think, oh, it's hot here, we can't do aeration cooling when it's hot. But even putting air over moist grain, you get an evaporative cooling effect. So don't be mistaken to think that you need an air conditioner system to cool grain. Just that airflow over grain with some moisture in it, you will get a great cooling effect, and you'll prevent molding, prevent insect infestations.
Yep.
We're only looking at getting grain ideally below 20 degrees. So it's not like we're trying to get it to fridge temperature, just below 20 degrees, down to those 15 degrees. None of the insects can actually reproduce. So below 20, it's less attractive to them. Below 15, they stop reproduction.
Yes.
I spoke about gas-tight storage for fumigation. Most of us look at the adult insects in grain storage and we think they're the ones we want to kill. As you well know, there's a life cycle, eggs, larvae, pupae, and in that life cycle, the egg and the pupae are the difficult ones to kill because they're dormant phases. So when we're doing a fumigation, we need to hold the gas in the storage at 360 parts per million for 7 to 10 days in order to kill all life stages of the insect. So we can't overcome a poorly sealed silo by putting more product in or repeating. We can't get around having gas tight storage. So I really want to reiterate that. because it's a huge decision at the time of purchase to make sure it's gas tight. And there is an Australian standard for that. And I've got these two graphs just to give you an illustration of a silo on the left-hand side that was gas tight sealable. Here's the gas levels, well over our 360 part per million range. Compare that to a silo that was the same silo right beside it, but we compromised the sealability just slightly, and you can see the gas levels were nowhere near what they needed to be. So there's an Australian standard, 2628, that can be referred to make sure the silos are actually gas tight. They're not just what someone determines might be sealable or fumigatable, but put a standard around it. We can do a pressure test on that storage and actually check that it is gas tight. We're not taking the word of the manufacturer.
Yeah, that's significant, isn't it? And I assume that has big implications around, resistance to to chemicals in the longer term if you're not managing that fumigation appropriately.
Absolutely, and it's why we've got resistance levels to what we do in Australia. Thankfully, we can still control most insects with gas-tight storage, apart from one with phosphine. We need to use a different chemical for one, but yeah, it's so critical when you're investing in storage. It's so disappointing when I hear people have bought storage and the manufacturer said, yeah, it's sealable. They buy the storage, get it home. They've bought it for 30 years. They can't trade it in or replace it or fix it when they find out that what they've bought is actually doesn't meet the Australian standard 2628. So must meet that standard. Grain quality management, as I said, is really about managing moisture and temperature. So as you mentioned, the first key to that is monitoring temperature and moisture. So there's the basic technology through to the more advanced. There's photos here of drying silos. They're dedicated for drying, and then aeration cooling on large flat bottom silos as an example here. But all very possible to do. There's some pros and cons to different monitoring equipment in terms of its ability to handle fumigation. So that needs to be considered as well. If the silos plan to be fumigated, we need monitoring equipment that can withstand that fumigation.
Yep.
To summarise management really quickly, because that's not the focus of today, but I thought if I give you an overview of managing grain in storage, that will help direct the planning phase of the storage infrastructure. So the pest prevention options, we've got hygiene structural treatment, something to think about, making a site easy to clean. Aeration cooling is absolutely paramount. We've spoke about protectants are a spray-on product for cereal grains, and of course some sort of monitoring equipment, whether that be electronic or physical monitoring. We need to be able to check the grain during storage. Pest control, when we do have issues, we need to be able to fumigate in gas-tight storage. And then, of course, if we want to deal with grain quality, we need to be able to manage moisture and temperature. Moving towards the end, to help summarise the different types of storages, I'll go through the pros and cons of each. So that'll give us a good wrap up.
Excellent.
I've mentioned that Australian standard 2628. If people have questions on that, please feel free to contact me. I can't reiterate how important that is to a new build. Cone bottom silos can be built to that standard. They can be aerated. They are easy to empty and clean out because of the cone bottom, of course. They provide segregation. They can be monitored well with a safe ladder. So they really provide flexible storage period. You can store grain in those silos for as long as you like because you have the ability to manage it. They do cost a little more upfront, and depending on the setup, may need more auger moves than a bulk size storage.
And as you were saying, they're normally fabricated off-site, and in Australia they're moved on, in that form, aren't they? To site.
Most typically, yeah, like 10 tonne would be a really small one. 120 is about the size we can put on road freight in most states. You can build them on site, so like 300 tonne on site is a common one as well. They can be built much larger on site, but tend to be more expensive because our cost of labour here to get people to travel to site to build a silo becomes more expensive, but has its advantages as well.
Yep.
Flat bottom storage, really a lot the same as the cone bottom, except it's a larger capacity. Has a flat bottom and an outloading system inside the silo, so less segregation, but more for when you're talking 1,000 tonne upwards. They're a more cost-effective option than the smaller cone bottom silos. The real difference is when it comes to clean out. So these, as I said, have an outloading system in the bottom of them, but they still require a small amount of shoveling and sweeping to get the last bit out. And less ideal for pulses, because most of these outloaders are an auger system, so tend to crack pulses and damage the grain on outloading. So not ideal for pulses, and that's where
Okay.
you might choose a cone bottom silo, and if you want a bulk storage, you might choose a cone bottom silo that's built on site. So you still could have 500 tonne in one cell, so you're not shifting the auger all the time, but it's self-emptying, not going through an auger outloading system.
Yep. Okay.
Sheds, multi-purpose, lower capital cost. You can aerate in sheds, that is a possibility, but of course pest and vermin control can be challenging, very labour intensive to empty and clean out, and there is a contamination risk depending on what else can get in the shed and what was stored in the shed between each time the grain is stored in there. So,
And yeah, so you're talking about pulses. Do you find that pulses tend to, be stored more in sheds than silos? What's kind of your observation from,
we do, yeah. Here in Australia, pulses tend to get less issues with insects. So people get away with storing pulses in sheds and not having insect issues in the same time frame that if you had barley or wheat in that shed, you would
Yep.
expect you'd have insect issues. So they get away with storing pulses in there. Still usually for a harvest logistics, so putting it in there a few months later, start out turning. Unless there's people that have gone down the track of putting aeration cooling in a shed, and then they'll store for longer term and prevent insects with aeration cooling.
But that's not the aeration cooling in a shed, isn't that common, is it? Well, from a
It's
system here
not.
in Australia? No.
It's not that common. The leading growers that really want to utilise a shed and have the option to store in a big year, they overflow their silos, so they want some overflow storage, put it into sheds. And if they've got a big year and the price is low, they want to hold the grain until the price recovers. So that could be 9 months, 12 months. So having the aeration cooling gives them a better chance to be able to hold the grain until the price recovers.
Yep.
Bunkers, here's another example of a bunker, more on-farm style without concrete sides. They're obviously a lower capital cost up front, flexible in terms of how much and whereabouts, although the location is really key to being able to manage moisture and keep water out of a bunker. They do require more labour, obviously. Grain quality control is limited. Risk of loss and damage is a bit higher than a permanent storage infrastructure. And there's a bit of work involved in doing a fumigation successfully in a bunker. So for an on-farm situation, I would say overflow storage, temporary storage.
Yep. And so from a fumigate, you would probably advise them to ship it out before they have to fumigate it, or put it into silos to be able to manage that. Is that
much easier to manage in a silo for a fumigation? It is possible in a bunker, but it's going to need to be a bunker better quality than what we're looking at here. So some sort of sides where you can clamp the tarp down to. The concrete sides are ideal and well sealed between each concrete
Yep.
pillar, good quality tarp, top and bottom, all those sorts of things, and monitoring equipment. So if we've got a silo that we know is gas tight, we can do a pressure test. We can be confident to do a fumigation. In a bunker, much harder to do a pressure test on a bunker, so we need to have monitoring lines to check our gas concentration in a bunker. Bags I mentioned and showed a few photos. So typically sort of 250 tonne in a bag, but you don't have to fill a bag. You can put a small amount as you like in a bag. For a site that's taking grain in from various growers, to be able to load different bags from different loads coming in would be logistically challenging. Once a bag is started loading, you want to load that whole bag unless you had multiple inloaders to be able to load several bags at once. But again, I would view bags as a more of a shorter term storage. If they want to become long term, they need to be managed particularly well to keep moisture and vermin out. There's not a lot we can do to manage grain quality in there, so I would always put grain that's of storable spec in there, definitely nothing over moisture. And I would preference my higher value, higher volume grain and lower value grain. So cereals, really well suited to bags. If it was me personally, I'd be putting my high value pulses into a silo. And the point I started with, cheap is not always better. So if we start a storage planning with price in mind, we're likely to get a result that's price driven. If we start a storage with the end goal in mind and the purpose of the storage in mind, and then start looking at price, we're much more likely to avoid issues like we've got in this photo here. To summarise the key points, prioritise the purpose and the function of the storage before considering cost, as I just said. Include pest prevention as part of the management, not just throwing fumigants at it. We need to do pest prevention as good practice as well. That would become cost effective for us in the long run. Even with good pest prevention, assume we will need a control option, so some way to fumigate in gas-tight storage when required. And to remember that permanent grain storage is a 30+ year investment. So cutting corners could mean 30 years of trouble. It's not like other equipment that we can trade in and upgrade and get a better one. We really need to get the right type of storage first up.
I think that's a great point, and we've kind of gone. You started with the planning process, and you got to think about where you want to get to in the longer term with the development of this. And we can drive around the country and see a lot. There's grain storage systems that were built nearly 100 years ago now that are still there and still operating. So it is a long-term investment that you have to think about when you want to go down and invest in in updating and grain storage systems. So I think that's a great overview, Chris, of kind of the systems that we use here in Australia, and I think hopefully give our colleagues in India a good understanding of what we do here in Australia, and that there are many different options that can be utilised to store grain. Yes, there's a lot of planning and understanding of what you want to achieve out of it to deliver the best result for your business or your community that you're operating in. So I think you've provided a great overview of that today, and appreciate the presentation.
You're most welcome. I think it's commonly understood that grain storage should be simple. You put the grain into a storage and then go and pull it out when you want to. But there's so many ways you can do that successfully that it does become a little more complex. So understanding there's more behind the silos that you drive past and may think are pretty simple. There's a fair bit of planning that goes behind a system that works well.
Excellent. Well, and Chris has provided these details in the presentation. If people want some more information or whatever, you can reach out to Chris by his email or mobile. And but again, thank you for your presentation today.
You're most welcome. Thanks for the opportunity.
Cheers.